Alrighty, hi guys. So we're now looking at probability. So we only have two topics left to go for this whole year in terms of what's leading into your exam. So the first one's obviously probability, and the second one is what we call travel graphs. That's the second one. Now, I would really like to have all of this done kind of by next Monday, and I think that would be ideal for where we are at the moment. I think we can knock out probability probably in this double lesson, and then using Thursday as consolidation and a bit of time to do some extra work. And then Saturday we can start travel graphs. Monday we can finish it off, and then we'll be done. Okay, and then you can start revising for your assessments. Okay, So looking at probability, the first thing I would like you to do, if you have the resources and you can, is to hand make a die, okay? So I would like you to hand make a die, obviously 6 sides. You need to draw the numbers on the dice, however you would like. You can either put numbers or you can do it like, what an actual dice looks like. And then I would like you to roll that dice. Now I would suggest making it maybe using some sticky tape, paper, whatever you've got kind of lying around the house. I would like you to roll that dice 100 times and record the number of times you get each number. So how many times do you get a 1, a 2, a 3, a 4, a 5, or a 6? Okay, now from that, we're going to then, hopefully you'll be able to determine what the probability is of getting each number, and then decide whether or not is your dice fair, because that's the main thing. So if it's fair, then you should have an equal probability of each of these things. If it's not fair, then you might end up with 7 more 5s than you do of any other number, and that means that you might be slightly weighted towards or slightly biased towards a 5 side. And this is a really important thing in probability, because with probability we have what we call theoretical probabilities, and we also have experimental probabilities. Okay, theoretical probability is what we kind of expect to happen. So when you roll a dice, you might think your probability of getting a 2, okay, you think that might be 1 out of 6 because there's 1, 2, and there's 6 sides altogether. So you might think that's 1 out of 6, your theoretical probability. Experimental probability is what actually happens. Okay, and the only way you can determine that is by testing. And the formula for experimental probability, say for the probability, we'll call it X, okay, is the number of times something occurs, okay, divided by the total trials, okay, total times you do something. Now I have here on my calculator set up, this is a probability simulator app, so it's tossing a coin, and I have made the coin unfair, so it's not a 50-50 chance of getting either heads or tails. It's slightly different, and the only way we can work out what the probability is by tossing the coin. So I'm going to toss the coin. Okay, let's go plus 50 times. Okay, so we can see here, if I toss that coin 50 times, then just give me 1 second. Okay, so this is for the same coin toss, so 51 times. This column here, that tells me my cumulative number of heads. So I can see that after 51 turns, I got 13 heads. Which means that there was 38 tails altogether. So my probability, in this case, my probability of getting heads, okay, is 13 out of 51, because I got it 13 times out of 51. My probability of tails is, what did I say, 38 out of 51. Now, if I convert that to a decimal, that's a bit easier to kind of see, so 13 out of 51, okay, that's 0.25, and 38 out of 51 is 0.75. Okay, so there's about a probability about 25% chance of getting heads, about 75% chance of getting tails. And again, the only way I can work that out is by actually doing the test, by doing the experiment and checking. Okay, the next little bit we need to talk about is the probability of an event not occurring. Now, after this, I would like you to go on and do the first kind of Google Forms sheet, and then we'll come back and we'll do the second half of probability. This is actually, by the way, this is the first half of probability almost done by the time we've done this, which is very quick. It's only like a 6-minute video so far. Okay, so if we look back at our example where we've got the heads and the tails, and we got if we know that we have a probability of probability of heads, okay, being 0.25, okay, that means that because there's only two options, heads or tails, the probability of getting, we'll call it not heads, okay, which is tails, it's the same, not heads is the same as tails, we're getting not heads is 1 minus 0.25, okay, which is 0.75, which we know is true from back up here. Now, why is it 1? It's 1 because the probability of all the possible options have to add up to 100. And we know 100 as a decimal is just 1, like 0.00, okay, but 1. So we say it's 100% chance because something has to happen, minus the probability that we know, and that gives us the probability of the thing that we don't know. Okay, so I'm going to give you this scenario here. Okay, so alrighty, so we have this scenario: a bowl of chocolates containing Mars bars, dairy milk, and caramello koalas. A bowl of chocolates contains Mars bars, dairy milk, and caramello koalas. So that should be a full stop there. In random, oh sorry, I've done a terrible job of this. So we're randomly selecting the chocolates. There is a 0.45 chance of getting a Mars bar. So I'm going to write here, probability Mars bar equals 0.45. A 0.1 chance of selecting a dairy milk. So I'm going to write probability dairy milk equals 0.1. What is the probability of selecting a caramello koala? So we know that there's 3 options. So these probabilities added together, I'm just going to call that X for the caramello koalas. That has to add up to 1 because if you're selecting one of those chocolates, there's no chance that it could be anything else other than those. You've only got 3 things to choose from. Okay, so the 3 probabilities added together have to add up to 1 or 100. From here we can work this out. So we've got 0.45 plus 0.1, that's 0.55 plus X equals 1. Now when we're solving, we're going to minus 0.55 from that X, and we're left with X equals 1 minus 0.55. You can do that on your calculators, but it's 0.45. So there's a 0.45 chance of selecting a caramello koala. So I'm just going to write there, probability caramello koala equals, that's an equal sign, equals 0.45. Lovely. I'm just going to show you one kind of slightly harder example, just up the top here. Okay, so this is harder only because there's no scenario, and generally when we're doing things like probability and statistics, the question is actually easier if you've got a context. It's a little bit harder when you don't. So we've got the probability of something occurring. So we've got that thing has 4 possible values, 1, 2, 3, and 4. And there's the probability, and this is what we call like a probability frequency table. And there's the probability of each of those occurring. So the probability of 1 is equal to A. The probability of 2 is equal to 2A plus 0.1. Probability of 3 is 0.3. And the probability of 4 is 0.05. Now, again, we know that if those are the 4 options, then all of those together have to add up to 1. So we can put this in here. Okay, they have to add up to 1. Now, from here, we can simplify this a little bit. So you're going to remember your algebra. So we're going to collect the like terms. So A plus 2A, that's 3A. 0.1 plus 0.3, that's 0.4. Plus 0.05, that's 0.45, is equal to 1. So now we're going to take away the 0.45 again, same as we did before. And we're left with 3A, 0. 0.55. Why have you forsaken me? Here we go, 0.55. Okay, and then we can divide through by 3, cancel that out, and 0.55 divided by 3 is 0.183. Right, now from there, we want to find the unknown probability. So 1 and 2 are our unknown probabilities. So the probability of 1, that's just equal to A, so that's equal to 0.183. Now the probability of 2, to work that out, we need to sub in 0.183 in for A. So we've got 2 times 0.183 plus 0.1. Now that is 0.467. Okay, there we go. Alrighty. So I want you to have a go at Google Form sheet now and then come back and watch the next video. And that's going to be the second half of probability. Okay, alright, bye.